Morning. Still morning. Until lunch is morning. Welcome to Enhancing Productivity and Insight with the JDK tools. I'm very happy to be here in front of you once again to talk to you about Java. I'm currently working as a developer advocate for Java at Oracle, and I enjoy experimenting with different tools, JDK tools and others, and to talk about them. In today's session, we have an important goal to actually look deeper into how JDK tools have improved since Java 17 and how that can help you to code or to deploy or monitor your Java applications. So we're going to start with the source and class file tools, but before going into that, I want to ask you a few questions. Well, actually, a few questions about the Java version that you're using right now in production. So can you please raise your hand if at the moment you're using Java 17 in production? So we have a majority of the room using Java 17. Great. Can you please raise your hand if you're using Java 21 in production? Good, good. Congratulations. And is anybody on Java 11? I have a few hands here. Java 8? So the front row. Good, you have the resistance. Okay, but today we're going to talk about what happened after Java 17, but we can dive deeper into before that, after the talk, and talk a little more. And hopefully you're going to be inspired to migrate to the latest Java versions, Java 21, 22, or experiment with 23. So probably you know this drill. We're writing Java in an IDE most of the time, and then we're compiling that Java code thanks to the javac, to the compiler. We're running our programs with Java most of the time, even the jars. Yet, for a long, long time, we have taken advantage of the compiler because it has some standard standard optimizations that help our Java applications to be performant. This has been for a long time happening. It's not new after 17, and we love these things. So, and there's a reason that you're going to see that I'm reminding you about these. So these compiler optimizations don't require any flags. So you can run javac, and they come with your Java compiler. And the great thing about this is that, well, your constants are folded. There's a string concatenation that is folded by default. The constants are inlined. And of course, if there's any dead code there, that is being eliminated. Yet, the compiler has a few catches, a few things that were enhanced, fixed after Java 17. And now I'll need a little bit of your help. So this is an example of string concatenation of order of operation. And I would like to ask you, especially those of you that are using Java 17 right now, what do you think this prints? I'm going to leave, and of course, shout to me the answer. Louder. So somebody said foo bar. Raise your hand if you think it's foo bar, like Java 17 people. Okay. So we have an answer here. Anybody else? Any other takes? Foo bar 2 times, like foo bar. Okay, so foo bar. You know something. Well, ta-da, the answer. Actually, you're right. Before JDK 19, it prints foo bar. There was something going on with string concatenation. But after JDK 19, this has been changed to evaluate each argument and eagerly convert it to a string in a left to right order. So after JDK 17, actually this one prints foo bar, like somebody said here in the first row, because it was a bug with invoke dynamic-based string concatenation strategies that was introduced by JEP2 when the JEP 280 was done. And it was seen a little bit later in time, caught and fixed after JDK 19. So this is like a small catch with the concatenation. Now, lossy conversions. So if we are to write this code in Java, we are going to get an error. So we're going to get incompatible types. There's a possible loss of conversion happening because you're trying to convert a double to a long. However, when you're trying to do the same computation with a plus equals operator, or if you're using a similar operator like a minus equals, then this error before JDK 20, this code before JDK 20 shows no error, so you can go and try it. It's very interesting, right? But it's pretty much the same operation. So how come in one case you get an error and the other one, the compiler is fine? There was another issue with this. So what happens is that after Java 20, the compiler is going to see this, and it's going to show to you there's a word that should be a warning that you're trying to have a typecast in a compound assignment with possible lossy conversion. This is very important if you're handling conversions like this for, I don't know, trading applications or others. So you're going to get something like this if you're running javac on example.java, and you're going to get a warning for these. Now, another enhancement to the compiler was in JDK 21 about the fact that if you're trying to invoke an overridable method in a constructor, like in this case, you're invoking hash code in the constructor, this is pretty good. However, this is not a good practice as Java developers. We don't do this, right? But it was possible to do, so this was compiling. It was good Java code. And starting with JDK 21, if you are doing the same thing, you are going to get a warning about using this kind of practice in your code. So you are going to be told that, hey, you're trying to invoke this before the subclass was fully initialized. So be aware of this. If you were doing this before, it's a practice that doesn't work anymore with JDK 21. Again, trying also to enforce the good practices with Java, not just making sure that everything is correct when compiling our code. So these are a few of the changes that happen with the compiler, a few of the catches of the compiler. Many more are happening with it. But when it comes to usability, there was a change that was introduced to help us launching our Java programs easily. So in JDK 22, JEP 458 is proposing to us the ability to run a Java program that is supplied as multiple files, like in this case, Hello World has 2 files. We can run them as one unit simply by running Java Hello World, and you don't need to do any class path or also say, hey, you need to compile helper first and then hello world.java in order to run this. This is pretty useful when you're having also libraries. You're just adding those libraries from the class path. You don't have to worry all the time of just saying every of your Java classes. So it's much more easier to launch your Java files nowadays than before. So this is Java 22 is the final feature, by the way. So it's not something that it requires preview. You can use it directly. These are just a few of the launcher and the class and the compiler. Yet, there are a series of factors that make Java attractive, right? You love Java because, well, it has platform independence, or it has built-in security, it has some ongoing language evolution, but it also has something essential for us as developers, JavaDoc, because that part tells us on how we can use certain Java classes, interfaces, but it also stands as a point of reference for us when we are documenting our own code. And I know that there's been a lot of practices and a lot of thought about how we're documenting code. Do we need to document code? Code should be self-explanatory. It's true. But in the case of APIs, we still need documentation, and we need help when generating that great API documentation. And for that case, JavaDoc as a tool has improved itself as well since Java 17. So first of all, just a few goals for the API documentation. So in case you're thinking like, hey, documentation, it can come later. Does it really matter? It can be a boring task. Well, great API documentation helps you with, first of all, maintaining your own product. Then your technical users of your API can understand better your API by looking at that documentation. Similarly, as we look in the JavaDoc, we understand Java better because we have a great JavaDoc documentation. Then It also increases the awareness of your software. So if you're having great documentation, people will trust to use your library, your API, your software. It has good documentation, right? And of course, other developers can start quickly by trying out API examples. And there's a catch. Because, well, documentation is easy. We can write javadoc, we can write sentences, and nice, but examples usually take more time and take an extra care. So how can we maintain examples in line with our APIs, but also like making sure that we can test them and keep an eye on them? So luckily, in Java 18, there has been introduced a new feature to help us with that. So before Java 18, we used to wrap code examples with pre-and code because we want to have code that is nicely formatted in pre-formatted text, but also display special characters if we're using any of those with that code. However, that didn't give us a lot of control over indentation, so we had to make sure that we indent the code ourselves, otherwise in the documentation it might not look that great. And there's no way to highlight with pre-and code. So what do? And I extracted an example for a SOAP API resource. I know that probably nowadays SOAP is not such a nice protocol to use in our APIs, but back in the day when I started coding, one of the few things that I had to do is actually create a SOAP API and document it. And documentation took me way longer. And I pretty much used this in my documentation. And I used pre-and code because that was available at that time. So if I wanted to give examples, and I had to give examples to my third-party users to know how to use the API, I had to do a lot of pre-and code and put nice XML over there and make sure that I indented it properly, run a lot of times javadoc, see how that works, if it looks beautiful or not, and so on. And it took me a lot of time, by the way, to write that documentation, even longer than writing the actual API. So this was the, let's say, the way that we are used to do it. And the result looks similar like this. It's not bad, it's pretty okay for documentation. However, we can see here there's no way you can highlight things, there's no way you can add your own styling, so just pre and code are not enough. Then, how can I test my example? Because if my API is evolving, I always have to come back to that XML file and edit it and make sure that actually I'm not forgetting any validation for my API or something that has been changed. And yeah, have my end users know how that my API is behaving. So there are a few questions that I had as a developer, and it was kind of cumbersome to maintain that on the long term. Now, starting with JDK 18, we have a way to elegantly introduce code examples in our javadoc thanks to the @snippet tag. So we have a better presentation of this targeted code. We can control the way this is being displayed to our end users. We can highlight, we can choose to replace, we can choose to link different parts of that example with regions. So we can tag when we can put regions within our code as well. And if I am to refactor what I had before, well, that comes easy. I can just say @snippet and say, hey, this is going to be the language of XML. So make sure that you're formatting this as for XML. Maybe I shouldn't care that much as, indenting stuff anymore because, well, it's going to be XML. The snippet knows how to do it. Moreover, I want to highlight to my end users that they should be paying attention to the name of my fields, right? What they need to use in the request. So they should probably pay attention to the field. In that case, the name of the field. So what I did here is say, hey, highlight for me the element regions, but not everything in the element regions. I want you to bold only the name of that element region, the name and the value for that. So I could use regular expressions to do that and have it bolded. And my end result is looking like this. So now I can say to my end user, hey, this is the documentation for the user class. You should pay attention to this example, but also pay attention, that's very important, what is the name of the element and its value. And if we're going back to the elegant inclusion of the code examples and the connection to javadoc as a tool, as a JDK tool, well, the tag also accepts to give separate files that contain the content of the snippet. So this means we can test the content of that snippet and make sure that we're actually giving our end users something that is working and in accordance to our API. So let's refactor again our example. And in this case, I just moved everything that was XML to a user.xml. I can use a test, make sure that that's OK from integrity point of view of an XML. Less code over there, even better. The end result in the documentation is still going to be an XML example, but stored in a nice location, like in source XML file. So what JavaDoc came with an extra option of saying ---- snippet path, where are the snippets, so that it generates documentation, including those separate files that can be maintained along with your code and tested by using regular tools. But not just this is one of the greatest things that came after 17 with JavaDoc. Another great thing is that, well, you can have now interactive documentation. So CSS with JavaDoc has been for a while up there, but there was also a need, like maybe we would like to add our own scripts, make our own documentation dynamic. So we can do this with the ---- add script option. And by using that option, the file will be copied to the generated documentation, and a script element will be added to every generated HTML page. There is one catch to this one. The pages that serve only to redirect to other pages in your JavaDoc, they will not have that script tag over there. And the nice thing is that you can use the option to add multiple scripts to your generated documentation. So it's not just add script in one file. You can do this for many more files over there. Something that I forgot to say about the talk, it has links to the changes and to the things that I'm talking about so that you know when that appeared and, of course, where that is documented, either in the JEP or in the GBS issue. So let's go look again at documentation and what can be done better. Now, JDK 23 comes with a final feature in terms of making documentation even better for us Java developers, meaning having Markdown in documentation comments. So this enhancement actually is aiming to simplify our overall developer experience. We've been writing README files in Markdown for a while, right? Because it's easier to maintain those and to write those. It's less ceremony around those ones instead of using HTML, for example. So what this enhancement means is that it's going to preserve the capability to generate API documentation as we did it before with JavaDoc tags and with HTML. But in addition to this, we can use also Markdown syntax in our JavaDoc comments. So if we need to do this, if we need to indicate the presence of Markdown in our JavaDoc comments, we can do this nowadays with 3 slashes instead of the current slash and star syntax that we are using. So that's the way that we can signal that. Now, that choice of the 3 slashes is not just simplicity and compatibility, to look something that we have done before, because we have used the double slashes before. Now, 3 slashes is just a little extra that we need to do. But it's also in order not to change the existing syntax of the Java language, to make more ceremony around making comments, just simple comments. And if you're interested in how this would look like, I just extracted something from HTTP handler's class comment. So that's a real comment from the OpenJDK HTTP handles class. And that's how it would look like if you're transforming everything to use Markdown. So as you can see there, no more need for pre and code. I can say, hey, this is going to be Java code that I'm going to include there as an example. Also, when it comes to handling links, there's no need to use that link. We just can use simply the Markdown way of linking. And what else? Oh, yes, and if I have code that I want to highlight, like in this case, JSON handler, I can do that in between codes and say, I don't need to do that code JSON handler anymore. An important thing that you can observe here, that other tags like @since, for example, they will still be preserved and they will work as before. So you don't need to replace them, or there's no need to do any extra efforts for some tags. That's about the class file and the source tools, but now let's look to something that probably you would use much more in your day-to-day life as a developer, and that's it for development and deployment tools. Now, JDK comes with several tools that help you to streamline development. We're going to touch only those that had significant changes within the OpenJDK. And we're going to start with probably one of your favorites as well, JShell. You tried JShell, right? Can you please raise your hand if you used JShell at least once in your... Not that many? Huh. You don't know what you're missing. OK, I'm going to tell you a bit about JShell. So JShell is great for fast prototyping your Java code without going necessarily to your IDE. So you just open JShell in your terminal, and you can write Java code there. And it can give you feedback immediately upon your code. Also has a programmable API, so you can enhance. You can access also its API. It's open. It's there. So it's pretty cool. But one important change that came to JShell is that it can highlight deprecated elements, variables, and keywords. This was not before, and it was something that was wanted by many of the developers, like have this like in an IDE way. So if the IDE usually is kind of telling you, hey, you're using something that has been deprecated, please pay attention to this. But if you're in a shell, you need a way to have that highlighted as well. So you have those signs of minus minus in between the caps, or how do you call that one? So these is just a way to outline deprecated elements. But in terms of tools, JShell also allows you access to some of the JDK tools. So JShell tool is also good for interactive exploration of Java code and use JDK tools with it. Now, it supports routing scripts. Now, these scripts can be something that you're defining local, by the way. You can create your own, or you can use a set of predefined scripts. So you have a few sets of predefined scripts within JShell. Now, the default one allows just the default entries that you can use in the imports. JavaIC just imports all the JavaIC packages. Printing defines print line, other JShell, printf, and so on. And starting with JDK 21, you have tooling, which defines javac, jar, and other methods for running JDK tools within the command line interface from JShell. So, without further ado, let me show you how that works. Hopefully, my IDE is going to work for me today. OK, so let's do this plain command line way. So I'm going to say, hey, make me example for .java. Let's code something in it. Wait a minute. Let's use one of the JDK 21 features of less ceremony for the void main and say var check new boolean true. And I think it should be enough. Let's save this. Make sure that I'm using lead Java 22 and say JShell example.java. So when I'm doing JShell example.java, what the JShell tool does, it compiles this for me and tells me, hey, and also highlights, you're using something that has been deprecated and marked for removal. So please pay attention. And also it's great because it can show you a help and how you can use the JShell even better. But moreover, let's use the tooling. I already opened my session with JShell for my application, for my Java program. And in order to use the tools, I can just say open tooling. And that loads the tooling script that I needed before. But also, I can do /edit, because I can edit my file, but also /edit helps me with something else. It gives me how I can use the tooling scripts and which tools are available for me and how I can invoke them. So there's no need for me to necessarily go and investigate how JShell is running scripts and so on. It can also show me, hey, how can I do that? Well, I can do that by running the method itself, like say jar, and give them some arguments there, or I can use the runway and have the run the tool and the arguments there. Let's just put an exit here. Go back to the edit. And let's compile our application. Well, it was already, JShell already gave me a feedback, but let's compile it with javac in JShell. So I'm going to say example.java. Because I'm using void main, which is a preview feature, I need to say, well, compile this, but with -- enable preview. Well, there's a source that I need for this, and I need to say 22. Sorry, I need to give the option of 22. So this is pretty much like saying javac -- enable preview source for like Java 22, and the file itself, which is example.java. So let's run this. And I get the same result like if I would run this with the compiler in my browser. There are more other tools like JavaP. I think JPackage is also available there, and others. And this will be improved down the way. And when you're done with JShell, oh yes, /exit. Nice goodbye on this one. So let's just do a recap. I used tooling, and I said open tooling because I already had an active session. But the other way to use the tools within JShell, you can just say directly JShell tooling, and that loads the tooling script altogether. If you are, like I did, I use open tooling, and something I forgot to show to you is that you can use the tools invocation to check the available tools that you can use in JShell. So not just the edit part, but also the tools method that gives you all the tooling, the JDK tools that are available in JShell for you to work with. And you can execute a tool in a JShell session, like I did earlier with javac, or use the run command javac -version in this case, and you can see the version that is being run over there. So there are two ways of running it, javac and give them some arguments, or just say run the tool name and then the program arguments that you need over there. Okay, so another question for you. If I am to ask you, what tool would you use if you need to just say go locally and, I don't know, test or debug a simple client-server setup? What would you use in this kind of situation? What tool would you like to, would be your first tool to go to test a situation like this? I'm looking for options in the audience. And you can shout them to me. And I had people saying Docker, and somebody told me Wiremock. So I'm looking for more options that you would use as developers. Think of your own situations when you need to test, like a client-server setup. What do you use? Michelle is in the back and cannot hear her. She needs to shout. So the options that were told at other times that I ran the session was like, OK, Docker setup, because it's great, and Wiremock for testing especially, which, by the way, are great options. But there's another way to do this pretty quickly and checks all three of these requirements by using JWeb Server. So JWeb Server is another JDK tool that was introduced in JDK 18 and gives you access to a minimal HTTP server that can serve only static files. Now, it's a very simple server, obviously. It supports only HTTP 1.1, and it works only with head and get. The idea is, like in the case of JShell, to easily experiment in a client-server setup without a lot of fuss. And that's where JWeb Server shines. But let me show to you some use cases for JWeb Server. So if you need to do some web development testing, like I said earlier, simulate a client-server setup, and you have some static files that you need to simulate. Just start JWeb Server, and you have a server up and running, available to serve you files. Now, another good thing about it, you can use static files as API stubs, and you can have that as for web service prototyping. So you just dump a JSON in some folder, and ta-da, when you're starting with JWeb Server, you have a working API serving you JSON information, and you can test that specific path. It goes pretty easily like that. You can also bind it on the port that you would like to work. So it's not necessary. By default, it's going to use 8000, but you can also define your own with the -p option. And another use case is that you can do a search in a directory on a remote server from your local machine. So you can set up this remotely. It gets an IP, and you can do a little search in that one without any issue. It's pretty cool. But also, if you prefer to start it in a more traditional way with the Java launcher, it's a known module, so you just have to do java -module JDK HTTP server to start the JWeb server tool. Another cool thing about it is good for learning as well, but it has its own API, so it's programmable. You can make your own API that can serve you files in a desired way. So it's a simple web server class. Can help you with supporting if you need to do a file server on the spot. It has also a way to handle files, and is great whenever you need just to fast prototype something very easily. And you can even run it in JShell, like in the example here. So, just to give you a little overview of how programmable this is, I have a small in-memory file server. Let me make this bigger. That what it does, it actually creates in memory JSON files with a specific prototype in mind, and is running all that just locally. So it's using GMFS from Google, a library that creates a directory hierarchy on a specific path. And when I'm starting this server, when I'm starting my application, it will serve me a specific pattern of files in JSON, using this pattern here, like go for a run and replace distance and keys and so on. If I'm to run this, uh-oh. Come on, output directory not specified. Which one? Damn it. Okay, I'm not going to insist on this one. Let me see if I can. I'm going to run it a little bit later on the JPackage example. So another great thing about tools is that, in the JDK tools, is that nowadays we can also package self-contained Java applications for different destinations. When we distribute software, one common way that we can do this is doing it like an installable package. So this package is compatible like for Mac OS or for Windows or for any other destination platform. Now, this is a self-contained application. What it means that it can be wrapped into a platform-specific installable package to simplify its distribution for a certain operating system. And JPackage is the JDK tool that can help you with that. However, this tool for packaging self-contained Java applications, well, prior to JDK 19, installing a JPackage application in our operating system was something that was considered system-wide. However, in the case of our nowadays applications, we're not usually not all the time administrators of our own spaces where we install applications. We are just simple users, so we're more restricted. So if we are to install a JPackaged application, if we didn't have system-wide permissions, that could have been impossible. And if you're thinking, okay, JPackage is not going to affect my life, I'm not packaging my application every day for a specific platform, well, I can tell you that JPackage is widely used for modular applications, but most of all by applications that are based on JavaFX. And it has a cool feature. It runs automatically Glink for modular applications. So you don't need to run Glink first to generate a custom runtime for your application. You just run JPackage, and that's going to be by default outputted there. Now, when it comes to using JPackage, this is a sample command for using JPackage that is outputting an application image specific to an operating system. Because I'm having a Mac OS operating system, it's going to output my application macOS folder. And I can run that application as I would run any application on my Mac, just invoke it, maybe just point macOS GDemo app and is going to run. Apart from this, when using gpackage, there's a place called app, and there's a configuration info. That is made my gpackage. And that is actually what got modified after JDK 19 to support configurations per user. So if a packaged application, JPackaged application, is done, is installed after JDK 19, there's a way that the installation is going to go. So application launcher will look for that .cfg file somewhere in the user-specific directory. So it's not going to assume it's system-wide anymore. It's going to search for the configuration to launch itself somewhere in Linux or in those specific directories over there for Linux, Mac OS, or Windows. If it doesn't find anything in the user-specific directories, it's going to move up and is going to take the .cfg file from the installation directory. So it's going to look where is my installation happening, and I'm going to take over this one because, well, I didn't find anything user-specific. And if you're launching your application from the application image, then the application launcher is going to take the configurations from there and ignore the other two. So that's like more an hierarchical way of launching after JDK 19. Let's quickly go what happened after in JDK 17 with security tools. So there is a new version option for key tool and jar signer. So you can use now key tool minus version to find out for which JDK are you running those. And there are some updated options for key tool, meaning that you get a warning if you're using weak password-based encryption algorithms with, for example, -gensec key. And that is being done thanks to the -key algorithm option, which is used in conjunction with -gensec key to detect if you're using weak algorithms, and you get a nice warning like in the example here. For jar signer, there is a way to specify the class path of your security provider with -provider path. So we can now say, hey, there's going to be a custom key store that is available at this provider path, and it has the provider class, this one, for my jar. Also, after JDK 21, the alt signer and alt signer path options are not available anymore with jar signer, so these are gone after JDK 21. And details about the -provider path, links is over there. Last part, monitoring tools. So what do we get new in terms of monitoring tools within the JDK? And I divided this part in a few areas. So first of all, which technology is responsible for what? Now, the JFR tool that is provided with the JDK, the OpenJDK distribution, is great for profiling your application and collecting diagnostic data to profile your application. Now, if you need to continuously consume JFR events and connect them with other details about your monitoring, your infrastructure, and so on, JFR event streaming API is there for you. So you can have that in your monitoring tool, output it there, and correlate it. And JDK Mission Control is a tool that is not shipped within the JDK. It's actually a set of tools that is great for doing monitoring, profiling, and troubleshooting of your Java applications in a more visual way. So first of all, JFR is a tool. It got a new command in JDK 21. So this new command helps you with seeing aggregated event data without going to JDK Mission Control. So you can have a flight recording, and of course you can inspect the events that were caught over there using JFR view. For example, if you start your Java JFR recording with -xx flight recording, you just get the PID of your jar and use GPS to find out maybe where's the PID of that. So there's multiple ways that this can work. But for example, if you want to see, for example, which methods are invoked most by your application, you can use the JFR view hot methods option. And in this case, you can use JFR view with JCMD. So send a diagnostic command with JCMD to your jar file, for example, your name of your jar, imaging.jar in my case, and say JFR view hot methods. And this shows which methods executed the most for my running jar. Another good thing that came within monitoring, there are a few events that help us as developers. Now, in JDK 18, finalization was deprecated for removal. So in order to detect finalization and places in your code where you're using finalization, a new event type was added to JFR, JDK.finalization statistics. The finalizer statistics. Now, thanks to this one, you can detect which parts of your code are being used using finalization and have that in your JFR file. And it's, of course, enabled by default in default.gfc and profile.gfc configuration files that are shipped with OpenJDK. So it's, by default, helping you to identify that. Another important event is detecting the initial security properties. And now, as Java developers, we can detect and can see the security properties that our application is using in logs. So there are log properties when we're launching our application that we can set, and we can capture details about security properties in logs. However, logs can be verbose. We can lose that information. We need a way to extract that specific information from logs. So maybe streaming that information or capturing that information in a GFR file, profiling file, would be easier and helpful for us as developers. The way to do that, well, it comes by default enabled, but if you need to disable it, you can use GFR configure, like in the example here, or you can disable it when you're launching your recording, when launching your Java application. So by default enabled, but you can disable it on your wish. If you want to get details about your security provider instance, there's a new event as well, JDK Security Provider Service. It gives you information about how many times you invoked a certain provider, but since GFR events are also captured in the recording file in a way that is showing the connection between them, you can also see which providers were accessed by your application, in which order they invoked by that. So it's a pretty useful event. It comes disabled by default in the GFR configuration files, but you can always enable it with GFR configure or with when you're starting your flight recording on launching. And now a little bit about JMC. Now JMC got some improvements as well. When I first did this presentation, JMC version 8.3 was there, the most recent ones. And that one got upgrades on JMC graph views, like you see in the slides here. However, at this moment, JDK Mission Control version 9 is the latest JDK Mission Control version that you can use. And some important details about it is that JMC 9 requires minimum JDK 17 to launch it. So if you want to use the latest and the greatest JMC 9, minimum JDK 17, I know. But it comes also with another nice feature. So if you know JDK Mission Control, it didn't have a dark mode. Now it has. So JDK Mission Control 9 also supports now a dark mode way of working, which some of you might find nicer in terms of inspecting your monitoring your Java applications. The flame view graph has also been enhanced since 8.3. So now you can aggregate the flame graph and stack trace by selecting the required attribute in the samples dropdown, and you can select either allocation size, sample weight, or TLAB size. So this is something from 8.3 here. And starting with JMC 9, flame graph will be rendered with Java Swing. I know, probably a small detail, but in terms of performance, the team realized that using Swing is better than the framework that was used before that. So just an example on how you can find the sample view in JMC. And the dependency view now represents aggregation of events using hierarchical edge bundling. So this means that it helps with visualizing dependencies between packages of your application. Simple way and a simple example over there on how you can use that and how that looks like. So that's what the hierarchical edge bundling was referring to. You can see the dependencies view of your application, and you can also select the package depth from the drop-down there as well. Now, sitting between you and lunch, so I'll wrap up the presentation. If you want to stay tuned for more what's going on in Java, there are several options where you can find out more. So the written version and where you find tutorials is dev.java, and we are welcoming community contributions as well from you to enhance the knowledge about certain aspects of Java. So we're accepting requests over there for content, but also your propositions in terms of what to be on the website. Inside.java is just a place where you can find the latest news that are happening within Java, what jobs are targeting JDK 23, for example, when branching of the JDK has happened, and other articles on maybe on data-oriented programming, like the ones recently written by my colleague Nikolai Parlog, and other useful stuff on how to use Java that are more now Java at the moment, Java of the now, that is not landing on dev.java tutorials. And if you like videos, we also have a YouTube channel, youtube.com/java, where we regularly publish videos, like tutorial videos, but also shorts if you don't want to spend more than 1 minute in learning something new about Java. A few places with the useful links that can help you understand even more from what I presented in this presentation, especially there is a lot of written part and written tutorials that are available on dev.java, inside.java videos, and I just got them all together, bundled here in the videos here. And thank you, everybody, for coming to my talk. Here's where you can give feedback, and that's where you find the slides with all the links and everything, so you don't need to take a lot of pictures and so on. Thank you once again for welcoming me. Enjoy lunch.